All right, guys, here's the second video today. Just some basic terminology with angles. Obviously, I'm sure that you've worked with angles before. Okay, and so anytime we have two rays and they share an endpoint, so they both rays start at the same point, okay, it forms an angle. Okay, so a lot of times, rather than calling the two rays, rather than saying the rays, we call them the sides of the angle. Okay, and obviously this vertex is the shared starting point. Okay, and obviously it acts like a hinge, so we could pull these two sides or rays further apart. Okay, or we could push them further together. Okay, to make a whole bunch of different angles. Okay, so we have the vertex. Okay, and then it's important, and this is kind of like common sense, it's important to differentiate between the interior and the exterior, okay, because that comes into play with a number of different postulates and theorems down the road. Okay, so anything inside the angle is considered to be in the interior, and anything that's not inside the angle is considered to be in the exterior, okay, of the angle. So we have interior points inside, exterior points outside. We have the two sides, okay, which are both rays, and they have a common beginning point, which we call an end point, and that is called the vertex. Okay, so I'm sure you guys have seen that before, I have no doubt about it. Okay, naming angles. Okay, it depends on what information you're given. Okay, in some diagrams, they just stick a little number, okay, in the interior, and they snug it up close to the vertex. Okay, so if they allow you to do this, we can just call it angle 2. Okay, and we know that it is the angle with the 2 in the interior, snugged up against the vertex. Okay, now notice in this diagram, we only have one angle. Notice there are no other angles that have anything to do with the vertex whatsoever. So if that's the case, where there's only one angle, we can name it just using the vertex. So I could call this angle P if I wanted to. Now it's real important that a lot of these diagrams, and you'll see one on the next slide, you have multiple angles sharing the same vertex. If that's the case, then you can't call any of them an angle P, because it's, leads to some ambiguous information. You don't know what angle you're referring to. But in this case, since there's only one angle, we can name it just using its vertex. So angle 2 and angle P are the exact same angle. Okay, the third way to name it is by taking a point along one side, the vertex, and a point along the other side. So when you name it using 2 points on the sides in the vertex always has to be in the middle. So I could call this angle QPR, or I could call it angle RPQ, like this. Okay, notice that the vertex P is in the middle, okay, when you name it. So QPR or RPQ. So you start along a side, go through the vertex, and go down the other side. Start along a side, through the vertex, and down the other side. Okay, some things that you couldn't do. Okay, can't name it this way. Can't start with the vertex. For instance, I couldn't say angle PQR. That's a big no-no, because you can't start with the vertex when you're talking about using 3 points. Okay, another one, I couldn't say angle PRQ, because again, I'm starting with the vertex when I'm using 3 points. Can't do that. Okay, you can't start along one side, go from one side to the next side, then down to the vertex. So I couldn't do something like angle RQP. Can't do that. Okay, so anytime you're using a point on one side, the vertex, and a point on the other side, the vertex always has to be in the middle. You always have to go side, vertex, side, or side, vertex, side. Okay, so these two work out. Okay, perfect example of a situation where you have multiple angles sharing the same vertex. Okay, And this is a situation where when you're in this situation, you can't name any of the angles, just angle E here. Because you think about it, you've got an angle right here coming along this side, going to this vertex and up here. So you have this angle right here, okay? Then you have this angle over here coming down from this side to the vertex down here. And so we've got an angle right there. Okay, then you have an angle over here starting along this side, going to the vertex, and then coming down this side. So you have this angle right here. Okay, and then you have this angle in here, starting on this side, going to the vertex and going along that side. Okay, so you have 4 different angles there. And if you say, okay, angle E, well, which angle are you talking about? Okay, so in this situation where you have more than one angle sharing the same vertex, you can't name it just by using the vertex. You know, if I say, well, I'm talking about this one, it's angle E, and somebody said, well, wouldn't that be angle E too? Wouldn't that be angle E? Wouldn't that be angle E? They all have the same vertex. Okay, so given the information we have, okay, how do I name these 4 angles? So let's start right here. Okay, this guy right here. Okay, I have a 2 snugged up in the interior, okay, real close to the vertex, so I could use that 2. I could say, okay, that's angle 2. Okay, I can't call it angle E. I can't call any of these angles angle E. So I can use one point along one side, the vertex, and a point along the other side. So I go side, vertex, side. So I could call it angle BEC. Or I could go in the opposite direction. I could go side, vertex, side. So I could call it angle CEB. So any one of these 3 names would be fine for this angle. Okay, but you can't call it angle A. Okay, let's go up above here. Okay, notice I don't have a number snugged up down in the interior of this angle, so I can't use a number. Okay, I can't call it angle E, so all I can do is start along one side, go to the vertex, and go up the other side. Okay, so I could call it angle AEB. Okay, or I could switch that order and start along this side and go BEA. So angle BEA. So there's only 2 different ways to name this angle, okay, right here, going across here. Okay, let's go down to this guy. Okay, once again, I'm lucky enough to have a little number snugged up there. Okay, so it's in the interior of this angle, snugged up by the vertex, so I could call that angle 1. Okay, I can't call it angle E. I can't call any of these guys angle E. So I could start along one side, go to the vertex, and go down the other side. So I could call it angle AED. Or I could switch the order and start along the other side, start at D, and I could go D, down to the vertex E, and then over to the other side. So I could call it angle DEA. Okay, so 3 different ways to name this angle. Okay, just like over here. And we luck out because we have that little number 1. Now down here, this guy going across here, okay, notice I have no little number down here snugged up in the interior next to the vertex, so I can't use a number. I can't call it angle E because I can't call any of these angle E. Okay, so I could start along one side, go to the vertex, and up the other side. So I could call it angle CED. Or I could switch the order. Rather than starting at C, I could start it over at this side at D. But remember, you have to go from a side to the vertex to the side. So it would be angle DEC. Okay. Okay, so perfect example where right here I only had one angle, so I can name the angle using its vertex because it's only one angle, so there's no other angles that have that point P as a vertex in the diagram. But here, all 4 angles have point E as their vertex, so you can't name any of them angle E because it causes ambiguity. Okay, and then lastly on this video, I'm sure you guys have seen this before. Okay, the types of angles, okay, with regards to their angle measure. Okay, as you know, and I know you guys have done this back in elementary school and middle school, we measure angles in degrees. Okay, so if you have a right angle, it's exactly 90 degrees. Okay, and we use this little box in here, okay, in the interior, snugged up against the vertex. Okay, and that means 90 degrees. Okay, anytime you see that, that means it's 90 degrees, which means it's a right angle. And then if we have an angle that measures less than 90 degrees, so it could be from 0 degrees up to, but not including 90 degrees, okay, we call that an acute angle. So this guy, I mean, it could be, maybe it's a 50-degree angle, I don't know, okay? Looks like it could possibly be 50 degrees. So you have something that's in between 0 degrees and 90 degrees, that's called an acute angle. Okay, then we have something that's greater than 90 degrees, okay, but less than 180, okay? In Euclidean geometry, which high school geometry is, we normally don't go beyond 180 degrees, okay? So you look in here and you say, okay, well, I might have, something is definitely greater than 90 degrees. It certainly looks like it's more than a right angle. So, that might possibly be like, I don't know, 115 degrees, something like that. I'm just guessing here, okay? But just to give you an example, okay? So less than 90 degrees, for instance, a 50-degree angle, we'd call that acute. More than 90 degrees, 115 degrees, we'd call that an obtuse angle. And then if it's exactly 180 degrees on the nose, we call that a straight angle, okay? Because notice it just forms a line, okay? So we could consider any line to be a straight angle measuring 180 degrees. So acute, obtuse, right, and straight, okay? All categorized by their angle measure, and I'm sure you guys have all seen these. That'll be the second and last video for this week. See you guys in class.